Hello class, welcome back to our topic cubes and cube roots. This is a continuation of the topic that we looked previously about cubes and cube roots. We defined what a cube and a cube root is. We also gave a number of examples on how to find the cubes of numbers and the cube root of numbers. And we did look at the factor method of finding the cube root of numbers, and we also saw that a cube is a number multiplied by itself 3 times, and that gave us a basis on what we are supposed to be doing today. And today's discussion will be on cubes of numbers using mathematical tables. This is what we are going to discuss today, and I hope you have your mathematical tables with you, a pen and an exercise book that we are going to discuss this together. We are also going to give a number of examples on the same, and these examples are going to guide us on how we are supposed to work out the cubes of numbers of any other number, that is. And we are going to see how we are going to go about it, and as well I'm going to guide you on the way forward. We are going to look at the following examples, and the first example is 0.0645. The second example is 509.7, and the third example is 723. These examples are just going to be a guide on the so many examples that you can come across on how to find the cubes of these numbers by use of mathematical tables. I'll guide you through, so don't worry, and we are going to look at the procedure on how to do it. And after that procedure, we are going to see how simple we can do it. And we are going to finally conclude what we have learned after this lesson. So our main objective of this lesson is the use of mathematical tables on how to find the cube of numbers. So welcome and enjoy. I hope the topic or the lesson will be interactive as we continue to discuss on this. It's a matter of cubes, and we know a cube is a number multiplied by itself 3 times, but we are going to use mathematical tables to find solutions on the same. So for today we are not going to multiply or literally use our calculators to multiply. We are going to find solutions on mathematical tables. So the procedure on how we are supposed to go about it is, first we are supposed to write the numbers in standard form, that is a times 10 raised to power n, where a is a number between 1.0 and 9.9, and n, which is a power of 10, is an integer. We know an integer is a whole number. Then we are supposed to find the cube of a using the mathematical table. As you can see there, when we write a number in standard form, we have two parts, a and another part 10 raised to power n. We are supposed to then to find the cube of 10 raised to power n and work out without the use of mathematical tables, since we have 3 as our cube, and that one will be like our the power. So 10 raised to power n, then raised to power 3, and this one we're just going to multiply the powers. So we are going to learn something new, that we can have the multiplication of powers, and of which it will be a very simple task for us, because multiplication of numbers, we have done them so far, and it is a simple task for us to do that. So we're going to see that we can multiply powers. So the integer n, we're going to multiply it by a 3, which is a power in this case. And in this case also, just to remind ourselves, is that a must be a number, and it is a must be a number that is between 1.0 and 9.9. Any other number that is not within that range should not fall under our discussion. So we have to ensure that our numbers a must fall between 1.0 and 9.9. Writing these numbers in standard form, the ones that we have given examples, for example 0.0645 can be written as 6.45 times 10 raised to power negative 2. Why negative 2? It's because the decimal point has moved 2 places on the light. And we have 59.7 can be written as 5.97 times 10 raised to power 1, where 1 is positive, meaning that we have taken the decimal point 1 place on the left. 723 can be written as 7.23 times 10 raised to power 2. I think that's a very simple exercise. If you look at all these numbers, 6.45, 5.97, 7.23, all falls under our rule that the a must be between 1.0 and 9.999. So, and then we cube that, so we just apply power 3 for all these numbers. So it is a bit a simple exercise. And if you look at 10 to power n, we are supposed to cube that as well. So I think it is a very simple exercise. So we apply power 3 on all these numbers. So as we continue, first by use of our mathematical tables, it will be 6.45, 5.97, 7.23, and these are the numbers that we are going to check the cubes of them in a mathematical table. So, and then the rest part, which is 10 raised to power n, where n is an integer, we just cube that and we just multiply the powers of 10. So it will not be very hard for us to do that, because like negative 2 is a power multiplied by another power 3, finally we shall see that it will be negative 6, and the rest follows. So to continue with the same, you'll find that after simplifying that power, that part of 10 raised to power n, you'll find that the power will be multiplied by another power 3, and that one will give us, like in the first case, negative 6, in the second case will be 3, in the third case will be 6, so that the part of 10 raised to power n will already be solved. The only part that will be remaining will be that part of the numbers that ranges between 1.0 and 9.999. And which are these numbers? 6.45, 5.97, and 7.23. These are the numbers that we are going to check in our mathematical tables. So are you ready to go with me and check the cubes of 6.45, the cubes of 5.97, and the cube of 7.23? I hope you're ready. Take your mathematical table, a pen, and also somewhere to write on. So to start with, we are going to find the cube of the first number, which is 6.45, using our mathematical tables. So open the mathematical table on the page of the cubes, and the first number is 6.45. So on the x column we look at the number which is 6.4, because the x column carries those numbers that are up to one decimal place, and then the third decimal number will be checked on the x row on top, which is 5. Then if I do that, I'll cross check the number that coincides with the 6.4 and 5. So that number that coincides with both of these numbers, both on the left and on the top of the table, is the number which is 268.3. Look at that, very interesting. Where my rectangular boxes meet, it's where I have my solution. It's very interesting. I hope this will be a very easy task to cross-check the answer with you. I hope that is what you're getting, because as you can see, whatever I've done with, I've circled 6.4, I've also circled the 5, that is the second decimal number, and you cross-check on that. The number that is tallying with my 6.4 and 5 is 268.3. Then we have another number which is 5.97. I go to the x column and I check my 5.9. I circle that. I go to the x row. I check my 7 on top there, and I have my number. I cross check the number that coincides with the two values, 5.9 and 7, and my solution is 212.8, where my two rectangular boxes are meeting. So you can see it's a very interesting way of doing it, and it's a way of showing you that we can find the solution of these numbers, the cubes of the numbers that we already had, that lies between 1.0 and 9.99. So as you can see, I'm circling 212.8 as my solution. And our last number that lies between 1.0 and 9.999 is 7.23. That 7.2 can be found on the x column, and down there we have it. Then we have along the x row on top we have the 3. So I cross check. There is a number that coincides with the two values, 7.2 and 3. On the left and on the top, directly vertically, you'll find there is a number that coincides, and if I cross check, my number is 377.9. Look at the rectangular boxes. Where are they meeting? Very interesting. Where they are meeting, we have the solution, and that is where we have the solution. So in any case that you're finding the cube of numbers, first ensure that you have written the numbers in standard form, because our tables will just carry numbers between 1.0 and 9.99. Therefore, you'll be able to work it out. After that, as I've shown you with another color, the blue color, that we have the solutions where our rectangular boxes are meeting. So very interesting. I hope you have enjoyed the way we have worked out the cubes of numbers, but we have to ensure that our numbers lies between 1.0 and 9.999. That is a condition. So the solutions of the numbers that we had, remember our numbers were 0.0645, only that we ensured that we have written the numbers in standard form. So after checking the solutions in our mathematical tables, the 6.45 cubed has given us 268.3. We also cubed 10 raised to power negative 2, and it gave us 10 raised to power negative 6, because minus 2 as a power multiplied by 3 as a power will give us minus 6. So as you can see, our result will be 0.0002683. We have also checked on the cube of 5.97 using our mathematical tables. What has it given us? It is 212.8. And also we have cubed 10 raised to power 1. Cubing 10 raised to power 1 gives us 10 raised to power 3. 1 times 3 is 3. So after that, simplifying that, will give us 1212,800. Then the last number, which is 7.23 cubed, we have looked at that. Then the 10 raised to power 2, again we have cubed that, but not by use of a mathematical table. The only part that we have used mathematical table is 7.23. The answer that we have gotten is 377.9. And then cubing the other part gives us 10 raised to power 6, and that is 377,900,000. So in conclusion, we have checked that we have used the standard form, we have known how to write a number in standard form, we have known how to use mathematical tables, and how to multiply the powers. And I hope that you have enjoyed, and this one will take us to the next lesson. So check our next video. It will be on cube roots. We shall find the cube roots of numbers using the same table of cubes. So don't keep far, be near, as we will be discussing the cube root of numbers, as we have done on the cubes of numbers. So still be with your tables, stay with them, and we shall be reminding ourselves even on the prime factors as we continue to discuss about the cubes and cube root of numbers. So we'll be mentioning about the prime factors, the standard form, the use of the tables, multiplication of powers in this topic of cubes and cube roots. So enjoy your moment as you wait.